So this is a slide that we've seen before. We saw it in the last presentation. And what it's showing is a regional metamorphic event where we have these two continental margins that have collided into each other and creating a mountain by folding all the sedimentary strata. And then throughout the core of the mountain, we have different levels of metamorphism. We start with slate in the edges where we have some horizontal pressures but very little heat, and we move all the way down into gneiss where we've actually had recrystallization of minerals and actually physically flattening out minerals through the amount of pressure. So great amount of heat and pressure. If you see in this little inset, you can see sort of the relative metamorphic grade that each one is experiencing. All right, we've got shale up at the top, which doesn't have any metamorphism, right? It's a sedimentary rock. Moves into slate with some pressure and little heat to phyllite, to schist, to gneiss, and then we actually get into partial melting. Partial melting being when the rock is so hot that it's actually melting rather than remaining a solid. Remember that after it melts, it's no longer a metamorphic rock, it's moved into an igneous rock. That partial melting zone is what's called a migmatite. So that migmatite is beyond the boundary of metamorphism. It is back into igneous following the rock cycle as rocks melt. So this is the whole story behind metamorphism, and we're going to dig deeper into the various parts of it.